This is the presentation for our system that we call ClassClone, a combination of digital twins and simulation technology to aid public classrooms. Public classrooms, especially here in the Philippines, are especially complex. Many classrooms are overcrowded, noise levels are high, and schools operate with limited budget for equipment and resources. On top of that, there are everyday challenges, heat, distractions, and different student behaviors that teachers must manage at the same time. Because of this, teachers constantly make decisions in real time, often rely mostly on experience and intuition. But when schools want to try something new, whether it's a new seating arrangement, teaching method, or classroom policy, those changes are usually applied directly to real students first. In other words, schools often have to experiment in real classrooms without knowing beforehand if the solution will actually work.
Before we talk about our actual system, let's look at the emerging technologies involved. Now, our first emerging technology that we use for our system is a digital twin. Now, a digital twin is a real-time virtual replica of a real system. So, let's say, for example, this smartphone. Let's say this smartphone has a digital twin. If we turn on this smartphone, its digital twin will also turn on. The reason for this is that, let's say, for example, that this smartphone has physical sensors built inside it. This allows the sensors to send real-time data to the digital twin. This is how digital twins will work. Now, for simulation. Now, a simulation is made using data, algorithms, and modeling. And it allows us to test scenarios and predict outcomes before applying them in real life. So, using these together allows for observation, testing improvements, and predicting outcomes. Now, how would we use this in our system? Well, using a real classroom. Using a real classroom, we would use digital twins to create a virtual real-time replica with sensors on the classroom. And then using simulation, we simulate variables such as teachers, students, the time of day, the actual date, and number. Okay. And after that, After that, we can predict outcomes and behavior, and our system would suggest recommendations to the user of the system.
Okay, so imagine a classroom where every decision you make, like for example, seating arrangement, teaching style, and classroom equipment has a predicted outcome before you even try. So instead of relying on trial and error on real students, teachers can now test their ideas virtually. So this is ClassClone. It uses Arduino sensors plus digital twin simulation, such as noise levels and temperature and humidity. So now let me walk you through our class simulation. So first we start our simulation. Then on the left side of the screen is the control panel, which allows teachers to adjust the classroom settings, for example, the seating layout, the teaching strategy, for example, the class discussion, time per day, simulation speed, and class information. Now on the center of the screen, you can see a real-time simulation of the classroom where teachers can visually observe how the students may behave on different classroom conditions. Now, at the bottom of the screen is the behavior color indicator, whether the students are focused, collaborative, distracted, or disruptive. Now for the right side of the screen is the analytics dashboard, where we can see the average engagement percentage and the noise level of the classroom. And here are sample names of the students, their behavior, statistics, and classroom statistics. Finally, we have a recommendation generated by the simulation. For example, if the noise level are high or the engagement are too low, the simulation will generate or will suggest to adjust the teaching strategy or the seating layout. So now teachers can test ideas virtually to choose the most effective teaching for a real classroom.
So why is our system beneficial and impactful? So first, first and foremost, our system helps schools to make decisions for this school rather to avoid the trial and errors, which causes a lot of time and waste of resources. It also helps the school to make decisions that helps and improve the stakeholders more effectively. So another major benefit of this is that the system the system helps create a better learning environment for these students by analyzing the noise, the seat layout, the temperature, and the comfort. The system also makes recommendations to improve the focus and reduce distractions for the student, and also improve the overall classroom behavior. Another major impact of this is the use of the Arduino-based sensors, which is cheap, like the microphone, light sensors, temperature sensors, and seat sensors. This makes it accessible for schools with limited budget. Lastly, the system does not replace the teachers. It assists them since the teachers are the ones that makes the final decision. And that's all for